Here's the difference. Here's the reason we learned calculus. Whatever you want to maximize or minimize, you find its function. This is an A. Bless you. Take derivative, set equal to 0, solve. Okay? So if I want to maximize revenue as opposed to profits, I'm going to take the revenue function, take its derivative, and set it equal to 0 and solve. Okay? The profit maximizing price will always be higher than the revenue maximizing price. And another way to think of it is the revenue maximizing price assumes that your marginal cost is 0. I'll show you why. So to find the profit maximizing output is 8 and a price of 45. The revenue maximizing output is we're going to take the derivative of the revenue function, so this 85 minus 10q, and instead of setting it equal to cost, we set it equal to 0, which is the same thing as setting marginal cost equal to 0. Okay, so 85 minus 10q equal to 0. So now I'm going to get that 10q is equal to 85. So q is equal to 8.5, whatever that unit is. So price, if I can sell 8.5 units, like 8.5 gallons of gas, is going to be 85 minus 5 times quantity, or 5 times 8.5. Which is, what's 5? What is 85 minus 5 times 8.5? $42 or $42.50? $42.50. Okay. So price is $42.50. Okay, that's the revenue maximizing price. Okay. So you could say, why do we set marginal revenue equal to marginal cost to find the profit maximizing quantity and price? Ali, I don't know if you're going to be able to see this on this other board, but I'll have you take a picture of it here in a second. I just rewrote out question, was it 17 and 18? Yeah, so this is 17 and 18. I just used the numbers from that one, so we'll get the exact same thing. But you could say, well, if I want to find the profit maximizing price, or the profit maximizing output, I should create the profit function, take its derivative, and set it equal to 0. So the profit function is revenue minus cost. So that 230q minus 20q squared, and then I'm subtracting the cost. I just wrote that all out, and I distributed that negative here, because otherwise I'll forget later on. I didn't combine these q's for a reason. And that was just to show you, when I take the derivative of this part, like, because that's the revenue function, that's marginal revenue. When I take the derivative of the cost part of the function, that's marginal cost. And so instead of saying marginal revenue equals marginal cost, I could also say, if I take marginal revenue, the derivative of the revenue function, minus the derivative of the cost function and set it equal to 0, essentially what I've done is taken the profit function took its derivative and set equal to 0. And I get the same thing, 230 minus 40 cubed minus 30 equals 0, which is the same thing if I can combine, 40Q is equal to 200, because the quantity is equal to 5, and whatever price we found. It's just another way to think about it. Okay? So, whatever you want to maximize, if I'm trying to maximize profit, I want to essentially take the profit function, take its derivative, set it equal to 0. If I want to maximize revenue, I want to take its function, take its derivative, set it equal to 0. Okay? Yeah?
Should we also know how to find like a cost minimizing as well?
No, because generally what we're trying to do here is maximize profits. We're trying to actually maximize where the difference between the revenue and the cost is the, that difference is greatest, because on this what you'll find is that costs are lowest when Q equals 0, which isn't really that helpful to us. So not all of calculus is helpful, but this part is, okay?